Someone just threw away an old induction cooktop, and that's a huge win for me. I picked it up from the trash and brought it straight back to my workshop to see if I could give it a second life. The first thing I did was test it by connecting it to power, but nothing happened. Since it was completely dead, I started taking it apart. One by one, I removed every screw from the housing, lifted off the top cover, and exposed the induction coil inside. After disconnecting the temperature sensor and removing the remaining mounting screws, I unplugged all the wiring from the control board and lifted the entire circuit board out of the unit. At this point, the damaged electronics and the old frame were no longer needed, so I set them aside and kept only the induction coil for the rebuild. To modify the coil, I drilled 2 small holes through the coil assembly and threaded a length of 0.75mm wire through the openings. The new wire was carefully wrapped around the coil before its insulation was removed and soldered to one of the original coil leads. That simple modification created a third connection point on the coil, which would be needed for the new circuit. Next, I cut several small pieces of PVC pipe, glued them to the back of the coil, and mounted the entire assembly securely onto a piece of cardboard, creating a stable base for the rest of the project. Now it's time to build the new driver circuit, using components recovered from the original board. Even though the circuit board is no longer functional, it still contains several valuable parts that can be reused. First, I removed the screws holding the heatsink in place and carefully desoldered the IGBT from the damaged board. Next, I removed all 3 capacitors, since they'll be used in the new circuit as well. After salvaging the components, I mounted the IGBT back onto its original heatsink and connected a 470 ohm 5-watt resistor to the first pin of the IGBT. Once that was finished, I applied glue to the heatsink and secured the entire assembly onto the cardboard base beside the induction coil. Then I took the 3 capacitors, glued them together, and connected them in parallel using short pieces of wire to increase the overall capacitance. After mounting the capacitor bank onto the base, I connected one terminal of the capacitors to the free end of the resistor, while the other terminal was connected directly to the second pin of the IGBT. With that complete, I connected the newly added 0.75mm wire from the induction coil to one terminal of the IGBT. Another original coil lead was connected to the capacitor bank. For the power source, this circuit is designed to run on 12 volts. Since I didn't have a 12-volt battery available, I used an adjustable DC power supply and set the output to exactly 12 volts. The positive output was connected to the 0 point of the induction coil, while the negative output was connected to the third pin of the IGBT. As soon as the power was applied, the circuit came to life and started operating. To test the result, I placed a steel cooking pan on top of the induction coil and poured some water into it. After waiting for a short time, the water slowly began to heat up, and before long, steam started rising from the pan, proving that the modified induction system was actually working. This project shows that even an old induction cooktop that most people would throw away can still be reused for an interesting electronics experiment with a few salvaged components